In 11th question, it's given 1 plus tan square A into cot A by cosecant square A is equals to tan A. So we have to prove this thing. We'll start with left hand side. 1 plus tan square A into cot A by cosecant square A. So here, first of all, let's see what we need. So I'll see right hand side. Right hand side is tan A. So tan A, like little backward if I move. Tan A means sin A by cos A. So that means we need this thing. We need this thing. Once we get this, we'll get this also, because tan's value is sin by cos. So this is our main focus now. So same things we will be using. First of all, we have to see to which trigonometric ratio we have to change. Then we'll check all the relations. Then we will see if anything common we can take, and then we'll see any algebraic expression also. All those four things which we have already discussed. Now 1 plus tan. Here one square is there. So square is suggesting us to see the square relations. So square relations of tan. Tan's square relation is with secant. So 1 plus tan square A, it is equals to secant square A. This we have already learned. This is where we have to reach. This is the first relation I came to know, because I should know the relations in order to change the given trigonometric ratios. So 1 plus tan square is equals to this. So let's write down this. In place of 1 plus tan square A, we'll write secant square A. Cot. Because we know we need sin by cos. So that means we have to change. Change is the first thing I told you. And if nothing is there, nothing, actually we know we need something in form of sin and cos. So let's change everything to sin and cos form. So cot, if tan is sin by cos, that means cot, which is a reciprocal of tan. That is, I'll write here, that is cos by sin. Because tan and cot, they are reciprocals of each other. Then in place of cot, I'll write cos A by sin A. Cosecant square A. Again, let's see the square relations, because it is, or before seeing for the square relations, because if I see square relation also, I know 1 plus cot square A, it is equals to cosecant square A. But the thing is that we are changing this to sin and cos form. And why we are changing it to sin and cos form? Because this is my destination. Here I have to reach. So that means if cosecant is there, if I am changing it into its square form, I won't be able to reach here. So that means this we should not be using. Then, so first thing again, we have to go back, and first thing about change to sin and cos. Everything I have to change into sin and cos form. So this cosecant also, we know it is also equals to 1 by sin. In reciprocal relations we have learned that cosecant is equals to 1 by sin. So let's change it to that, because cosecant square means, this square means actually whole square. In very first video also I told you that if square is here, that means it is a whole square. And don't write square on the angle. It will be completely wrong. We always have to write square here. And this square also means whole square. So I can write it like this. Cosecant A, it's whole square. So cosecant I can write as 1 by sin. Then I can write it as whole square. Then one thing again, I converted everything to sin and cos form. But again this secant is there. So let's convert this also. Let's change this also to sine and cos form. So secant A, in reciprocal relations we have learned secant it's a reciprocal of cos. So secant I can write as 1. This square means whole square. So just to simplify, let's write it this way. So it is 1 by cos whole square into cos A by sin A, and this 1 by sin A. So this whole square, let's write it this way. And this whole square also, because whole square means square on the trigonometric ratio. So let's write it this way. So here what we can do, this is one fraction and again this is one fraction. So two fractions getting divided with each other. So let's simplify it more. I will write cos square as cos A into cos A. The square things, in every question I am telling you, square means like a number with multiplied by with itself. So 2 square means 2 into 2, so that means cos square means cos into cos, cos into dot, it's like multiplication, cos A by sin A. Because I have to reach here. Then this sign also, sin square, it's simplify it more. Sin A into sin A. Now here first of all let's solve like a numerator, then we'll solve denominator, then we can write it together also. 1 cos and 1 cos will get cancelled because this is one fraction and all the terms they are in multiplicative form, so we can cancel. So what we are left with now, here in numerator if we have to write, here nothing is there, so 1. In denominator I have cos into sin. Into means I can write a dot. Then it is getting divided by 1 upon sin A into sin A. So whenever two fractions they are getting divided, what we can do? We can change this division sign into multiplication. Inner ones we can multiply together and outer ones we can multiply together. And this sign will change into multiplication. First we'll write this, numerator will write, so that there won't be any confusions which thing to write first. So this thing only we will write first. Then we know outer ones will get multiplied. So this, I write as sin A into sin A. And then inner ones, this I have already written, this should be multiplied by 1. 1 sin and 1 sin. All multiplicative terms, up and down we can do cancellation. Sin, it will get cancelled with sin. Now sin A into 1, it is sin A, and cos A into 1, it is cos A. So that's what we needed, because sin by cos is equals to tan A, and this is what our right hand side, hence proved. Now let's do 12th question. See, in this question, in this one, we have done everything what we are doing from the starting, and all these questions now you can also try along with me. I'm sure you'll be able to do it. In this question we have used the change thing. First thing, you have to figure out to which thing we have to change. For that we should know their relations, and if nothing is there, because first of all I just looked at right hand side. So right hand side suggests me I need sine and cos. So we changed everything to sine and cos. After changing to sine and cos, it is just the calculation. Calculation means like it's the division of two fractions. So that's what we did here. Next question. Next question is very much similar to 10th question. Tan square minus sine square. This thing we have to prove it equals to tan square into sine square. So first thing we have to change it, and now to which thing we have to change it, that we will come to know if we just check right hand side. So let's take right hand side so that we can know where we have to go. A right hand side is something like this, tan square into sine square. Tan square is what? It is tan whole square. Sine square is sine A whole square. Tan is sine by cos into sine. So I need this thing. So again that means on my right hand side, if I get everything in the form of sine and cos, something like this, so I'll be able to reach here, because after reaching here, we'll move backward. So I start from here. Tan square minus sine square. So at the first step, we know we have to change it, but to which? So we came to know by just analyzing our right hand side that we have to change everything to sine and cos form. This is already in the form of sine. This is tan. So tan we will change into sine and cos form. Tan is equals to sine by cos. Because it is square, so I will write square with both. Minus sine square A. Here if I solve it, this will become something like that. Sine square by cos square into sine square. You can see also. So in denominator something like this we have already got also. Now this thing I have changed. Now out of those four things which I have told you, one thing is taking out common. Whenever we see something same in two expressions, this is one expression, this is one expression, and they are getting subtracted. So whenever we say that we see that something same is there and they are getting subtracted, or maybe they are getting added, that time we can take out common. Commons, that is whichever thing is same. So here sine is common to both the expressions. So this I will write outside. I have taken it out. So remaining thing is only we will be writing now inside. So sine square I have written outside. Now nothing is there. So nothing is there, that means 1 is there, because this is actually what? This is this expression getting multiplied by 1. Because 1 is a multiplicative identity. So into 1 if you multiply, we will get the same thing. So if nothing is there, so you have to remember, you have to write 1. Because this we have taken out. As 1 into sine we have written out. Now 1 by cos square A we should write. Here we have taken out sine square A. Now nothing is there, that means 1 is there. So I will write 1. So sine square A. 1 sine square A I have got it. Now that means this thing only, now I don't have to make change to this. This is what I need. Here also you can see. So this thing, let's write here also by 1 so that there won't be any confusion. This is also one fraction, this is also one fraction, and two fractions they are getting subtracted. So two fractions getting subtracted when their denominators are not same, we should take their LCM. The LCM of such expressions is this into this, multiplication of both the denominators. So cos square A into 1 is cos square A. And this side cross multiplication. So whatever we have to write on numerators, we'll do cross multiplication. So 1 into 1, 1 minus sign as it is. Cos square A into 1 is cos square A. Sin square A, I got it. And here if I see, now this also cos square A, I have got it. 1 minus cos square A, now we can check out for the relations, because here we need sin square A. So we know sin square A plus cos square A, it is equals to 1. So that means 1 minus cos square. If we shift cos square to other side, because we want to know what is the value of 1 minus cos square A. So in this relation itself, cos square we are shifting to other side, plus cos will be changed to minus cos. So sin square A is equals to 1 minus cos square A. that means in place of 1 minus cos square a, we can write as sin square a. So sin square a, and all these things you have to write because this time it's a subjective paper. So each and every reason why this thing you are replacing by this, you should mention all the reasons. Sin square, sin by cos is tan, because square is there, so we will write square. Sin square a into tan square a, which is equals to our right hand side also. So hence proved. So 13th question, it is similar to the previous question, exactly similar, only sin and tan now they are replaced it with cos and cot. So same thing, I'll see the right hand side. It is cos square a into cot square a. So cos square a into cot. Cot is what? Cot is cos by sin. So cos by sin, because square is there, so I write square. So what we can do, we need this thing. Now we are sure. So that means again everything, because first thing is change, and to which thing we should change, that also we should know. So we should change everything of the left hand side to sin and cos, because we need this thing. So left hand side is cot square a minus cos square a. So first of all we have to change it. So cot is cot square a by sin square a minus cos square a, as it is I will write, because it is already in cos form. Cot we change to sin and cos form. Cot is cos by sin, because square was there, so I just wrote it square also. Next thing is common. Common is also out of those steps which I have already told you. So common we can take cos, because it is present in both. So cos square a I will take as common. Now remaining things we will write as it is. So here nothing is there, like I have already told you, if nothing is there we should write 1. Why 1? Because if I write it, I will get the same thing again. So 1 by sin square a minus 1. If you multiply, see, cos square into 1 by sin, you will get this thing only. And again, if you multiply with this, with 1, you will get same thing. So whenever you are taking anything common out, that time after writing that expression, just multiply it again and check whether you are getting same thing or not. If you are getting same thing, that means you have done it correctly. If you are not getting same thing, that means you have done some mistake. So this, after taking out common, just once you check it also. Now cos square a, this we have got it. Now here we will write as 1 also, 1 by 1. These are two fractions, and fractions getting subtracted when the denominators are not same. So what we have to do? Yes, we have to take LCM. LCM of such expressions is their own multiplication of the denominators. So sin square a into 1 is sin square a, and what we have to write on the numerators, that is their cross multiplication, like this. 1 into 1, 1, minus sign, don't miss this sign, minus sign as it is, we'll write sin square a into 1 is sin square a. With 1, if you multiply anything, we will get same answer. Now cos square a as it is, I will write. Now see, we need cos. Sin square I have got this cos square also. Now this relation, because we don't need sin, we need cos, so that's why we have to change it, and for changing we should know the relations. So relation of sin and cos, and that too in their square relation. This is also square, this is also square. So we can see, we know sin square a plus cos square a, it's equals to 1. Now we have 1 minus sin square a, and here we need cos. So that means sin we will shift to other side. If we shift sin to other side, I'll get cos square a is equals to 1 as it is, plus sin will be changed to minus sin square a. This plus changes to minus on shifting to other side. So from here we got to know that 1 minus sine square a is equals to cos square a. So let's write it. Now we got this thing, exactly the thing which we need. Only thing is that cos square a into bracket means multiplication, cos by sine is cot, and both of these they are with square. That means actually whole square. Whole square means here we can write square. So cos square a into cot square a, cos square a into cos square a. So that is our right hand side also. So we can say hence